ASC Education Foundation, this one on the effects of contamination in modern diesel fuel systems. My name is Dave Kappert with ASC, and this session is being recorded. Before we get underway, just a little bit of housekeeping. Your microphone is muted by default and your camera is also turned off. So the way that you interact with us is through the questions pane. Now in today's sessions, we're going to reserve questions till the end of the content that's being delivered here today. But that wouldn't stop you from entering information along the way. If you happen to have a question, if it comes to mind, go ahead and type it into the questions pane. In fact, why not try it out right now and let me know that you can see and that you can hear and that we've got a sound broadcast. By all indications, everything looks good here, but it's always nice to get confirmation from the outside world. Okay? All right, fantastic. Getting some feedback now. David, Erica, Rodney, thank you very, very much. Appreciate your feedback. Now, even though everything seems to be going good right now, there's a chance you could always drop out of the broadcast during the session. If that happens, the quickest way we found to fix it is usually to simply just exit and then come right back into the session. Of course, your experience in this session is based upon how good your internet connection is. So if you are struggling getting good bandwidth during the broadcast, you're going to struggle during the session, and it's not going to be a good time during the session. But hopefully everything will be good, and we'll have a good quality session because I think we've got some good content here for you today. One more thing, you will receive a certificate of attendance for this live session. It comes to you by email with a subject line starting with webinar certificate attached. And that will include a link to that certificate. And as I mentioned before, this is a recorded session. It will also include information on the recording if you'd like to go back and review some of the stuff that's talked about here today. And if you decide to attend the recorded session, that also does furnish a certificate, which comes the same way by email. All right, without further ado, I am now glad to present Alberto Bonilla with Diesel Forward. We're now going to go to near Madison, Wisconsin.
Good afternoon, everybody. I hope everybody's having a great Thursday afternoon. As David said, greetings here from the Wisconsin area. Today I will be talking to you guys about the effects of contamination in the modern diesel fuel system. Introduction to myself, Alberto Bonilla. I've been with Diesel Forward for going on 11 years. I have experience in the fuel shop, working on injection pumps, the rotaries, and the common rail pumps. Also have experience working on the fuel injector side of it too. And yeah, just personally being hands-on working on the mechanical side and the common rail side is definitely put a better picture of how everything works in the diesel system. Alongside with me, I got my colleagues here in the technical support. You guys can feel free to reach out to us for any sort of information, or if you guys run into any troubleshooting information, or just have any questions, what should I do? So again, any of these guys here, along with myself, can give you guys a hand. So today we'll be talking about diesel fuel contamination. One thing with diesel fuel contamination nowadays in the modern fuel system is contamination kits. So contamination kits have became more relevant within the past 10 years. Prior to that, yes, contamination always existed, but the amount of damage that happens now and the traces that you leave behind, you just need to replace the whole fuel system. What's causing this? So emission regulations have gotten stricter as well. So that has led into the introduction of DEF fluid in our light duty vehicles. So DEF fluid, diesel exhaust fluid. The name itself can be very confusing with those who own a diesel pickup truck. It's one of the more common accidental contamination cases that are out there right at this time. To have no ease, the OEMs have made it pretty pretty easy to confuse either or by putting them next to each other. So you got diesel exhaust fluid and then you got diesel fuel right next to each other. GM had it pretty good for a while, having it under the hood, but with that came with guys guys and gals not using funnels to fill up the diesel exhaust fluid properly. So if you didn't know that the diesel exhaust fluid is highly corrosive, we were seeing and hearing of people just kind of dumping it into the fill neck under the hood and just getting it all in the wiring on the wire harness and being corrosive. It was causing shortages and whatnot in the wiring harness. So tighter tolerances in the modern day fuel system, along with the combination of more components. There's a lot more there to go. There's a lot more moving parts and things that go wrong. Contaminants nowadays, it's impossible flushing things out. They're, like I had said, there's a lot more components, and the size and the tolerances of these components, it's hard to inspect things and actually flush these things out and make sure you're going to have a good working system after you try to flush things out. Even today, I got a call of a contamination case on a skid steer, brand new, 150 hours, and they were talking about, what do you think about flushing it out? It's like, at this point, if you're plumb full of metal, that metal's going to be in your injectors as well, and you install those again after you try flushing them out on the test stand, you're going to be having the same issues. There's no guarantees of getting that out. So with that said, there are OEs as well. They have kits, not only in the aftermarket, but the OEMs have kits, and or they have bulletins with the parts you want to be replacing if there were a contamination case and the scenario. So I know Ford, for a fact, they got the little push start button now, where if the operator accidentally fills it with fuel, with gasoline or DEF fluid, it's still salvageable up to a point, as long as that push start button doesn't kick on the low pressure pump and move all the contaminants up to the rest of the fuel system. So just you gotta feel out what the customer scenario is, and then you gotta read through the procedures of what the OEs recommend. So not only are we seeing this on the light duty side of things, we're seeing I've been seeing contamination kits as well for these off-highway applications. The same thing goes with the pickups. They got DEF fluid being used in the after-treatment system. So those have been accidental cases on some of these skid steers or larger agriculture applications. So take it back here a couple steps. We're going to go to the mechanical fuel system, which the mechanical fuel system had a had a simple injector design, and the pump was the more complex unit of the system. Besides that, we had your fuel filter, you had your fuel tank, and your return line and supply line. Pretty cut and dry, and that pump was designed to make the pressure to overcome spring pressure in that injector and inject fuel into the cylinder. As I had mentioned before, contamination has always been a problem, and it still affected the mechanical legacy system, but they were a little bit more not as what do I want to say? They weren't, the price is doing the labor work and the parts component side of the modern fuel system compared to the legacy system it's quite different. So next we'll step into the modern fuel system. So in the common rail system, the roles are reversed. The pump is a lot more simpler, and the injectors have gotten a lot more complex compared to each other. We are seeing, excuse me, we are seeing fuel pressures up to 29,000 psi, depending on the manufacturer. When fuel pressure is that high, the fuel is moving at a quite high velocity. So any sort of micron or contaminants or debris or whatever of a micron or 2 microns inside of one of these inside the fuel system can start eroding quite fast and do quite a bit of damage to to an injector or various injectors or a pump. We're seeing up to seven injections per combustion sequence. Any sort of foreign debris in the fuel system will interrupt the sequence of injections and can lead to intermittent running issues. Another thing that we got to take in consideration, Ford and MaxForce on the international side, they use post injections to do the regenerations on the after treatment system. So having post injections when not needed, it could lead to damage to your after treatment system as well. So that could be caused due to contaminants interfering with the combustion sequence and leaky tips or what you have it. We've had piezo actuated injectors. We'll get into the piezo actuated injectors a little bit more, but as I had mentioned, flushing piezo injectors, as well as non-piezo, your CRIN 1, your CRIN 2, etc. Flushing those injectors, it's not recommended with there being a contamination scenario. Like I said, there's no verifying that we got every piece of contaminant out. CP4 injection pump was introduced to meet the OEM performance needs. The pump was designed for the system for high pressure. There are kits out there where they are deleting CP4 pumps off of your Duramaxes or your Fords, for example, to put CP3 pumps. The CP3 pump was never designed to be able to make the pressures that they are demanding. So one, the performance of the CP3 is not going to be up to the pressures that it's demanding, and you could see some flaws. Sure, there's tuning, but it's just not capable of meeting the demands that the system wants to see. The CP4, if treated well, doing some tricks and doing some tips that we'll be presenting later on, I think it would be, there's plenty of life on them. So introduction of the 9th injector, the LML, the Duramax LML started introducing the introduction of the 9th injector 2011 to do the after treatment on the after treatment side for regeneration purposes. So this is one component that we see and hear about people not looking over and replacing when there is a fuel contamination case. So that injector, it's seeing diesel fuel, not diesel exhaust fluid. It's seeing diesel fuel, and it's sharing the same circuit that your pump, your injector, and your rails are. So any sort of contamination being inside that fuel system, it's going to be there in the 9th injector as well. Like I mentioned, any contaminants could cause a leaky 9th injector. Although the pressures aren't very high, you could still get something lodged in there enough to cause a leak and cause premature wear to the after treatment system. So piezo injectors, piezos are crystal stacks inside. There's crystal stacks inside of the injectors. There can be anywhere in the range of 300 to 400 crystals inside. So when energized, the piezos expand to move the hydraulic coupler to act and create the injection cycle. Take note that piezo stacks can be damaged. So what I mean by that is on some of the Fords, I see it more so on the Fords and more so on the GMs, but the nozzle tip when removed them can be, if you got like a head gasket job that you have to do, but I mean the fuel system's fine, etc. I've heard of guys having and seen it in our shop as well, where they've had to take the slide hammer to the injector to remove it because it's got such carbonization on the nozzle. So with that said, having that much carbon on there, the vibrations of the slide hammer will impact the piezo stack and can collapse it and damage it and affect the performance. Piezos internally can internally short due to contamination. So DEF fluid or metal contaminants inside there will act like a wrench across the batteries and start arcing across, and that will short out an injector, leading to a dead miss. Usually will throw a fault code, but I've heard of instances where it doesn't throw a fault code. thing to keep in mind too with the return line on these injectors. On these kits, you'll see injector return lines being included. Good example is DEF fluid. It gets really, which I'll show some more pictures. It gets really crystallized and it starts creating a restriction. Well, the piezo needs a pressurized return fuel in order to work properly. Having a return plugged, on the other hand, would exceeding the tolerance of the pressures can cause that piezo stack to crash and cause a dead cylinder, a dead injector. So keep that in mind. Types of contaminants that we are seeing. Diesel exhaust fluid. Diesel exhaust fluid is made from 32.5% urea dissolved in deionized water. DEF fluid crystallizes and is extremely corrosive and harmful towards, very harmful towards metals. Like I mentioned earlier, it's a very common accidental scenario, and it's kind of one of the bigger ones that we see of water and or poor fuel. Water can come from a bad fuel source. Bad fuel sources are either you got underground tanks, poorly maintained, even tanks above, poorly ventilated, auxiliary fuel tanks on some of these construction trucks. If that tank isn't maintained properly, inspected or drained or anything like that, that can be a contributor to water inside the fuel system. Water, not only does it create rust, but it also cuts the lubrication characteristics found in diesel fuel. So one way to kind of avoid that is by running an additive that demulsifies water, which we will talk about a little bit later on. Debris, where does the debris come? For example, in that first slide that I had shown, that cab chassis pickup had the diesel filler neck in the back behind the wheel well. So road grime, dirt, construction, mud, whatever you have it's exposed, and guys are filling up. You mean you're putting your filler neck inside, knocking some of that stuff down in the tank, and hopefully that filter can catch that stuff. But sometimes there's times where it won't catch it, and or if the incorrect use of fuel filters is being used, that could contribute to debris being a factor in a contamination scenario. Gasoline, which has been a common one of accidental contamination. What that does, it acts as a solvent inside the fuel, cutting the lubricity and causing metal-to-metal wear on some of these components. Biofuel, yes, our fuel right now, there are some stations where they got biofuel blends, but most of these manufacturers are approved. As you can see, like Ford, I believe they got 20%. But not to get too much into detail, but they are out there. But what I'm referring to biofuel is the French fry oil, the stuff that smells like a fryer going down the interstate. Not as common anymore, but it's still out there. And that stuff, picture in the right-hand corner there, it can get really gummy and sticky and really throw the fuel system there for a loop. Incorrect or non-approved additives in the diesel fuel. What I mean by incorrect additives is alcohol-based additives and or chemicals, which disperse, emulsify, not demulsify, which will cause damage to the fuel system. And keep in mind some of these fuel additives, they can harm your after-treatment system if they are not approved for an after-treatment system. So a couple ways to do some prevention of, what we can show customers and what we can practice in-house of doing prevention to contamination. The use of a good quality filter, I mean, it can be easy to spend the $30 filter versus a $50, $60 good OEM quality filter. Technology in filters nowadays is quite impressive. They got wax coatings on there that help emulsify water. Good source of information is raycornews.com. They have really good information on the filtration and stories that they got in there. Even catalogs of what you can use for for filtration, or if you want to add an extra filter to your system or your customer system, etc. Check them out. Pretty good place. A lot of good information. Check the service manual for the OEM recommendations of service intervals for, I mean, not even, this is fuel, but oil filters, the rest of your fluid strands, and especially fuel. If you got repetitive customers, kind of keep them on track, and these guys will appreciate it. Cleanliness while servicing, while doing the service. That's a big key, is keeping the area clean. Some of these filters, they can develop, depending on where the truck's being used, they can develop a lot of dirt around the filter, and you spin it loose and you can drop some on. You can not get all the dirt or grime, whatever it is. Beforehand, inspect, clean it off, take a little bit of time extra to do that to prevent any sort of debris, dirt, grime, whatever getting into the fuel system. And like I had mentioned, approved diesel fuel additives. So proper steps to follow after a contamination case. As I mentioned earlier, depending on the service procedure, most of these manufacturers want to do a complete kit. Through Diesel Forward, we do offer some kits, and the ones that we have put together, they are going to be including the components that you need to do a job and do the job right. Good example on the 6.4 is the fuel cooler. There's I believe through Ford there might be a procedure where they might want you to flush that out. I don't remember if it was that or the 6.7, but looking at a fuel cooler, I mean, I wish I had a nice diagram of a cutaway, but maybe later on I could get one once I get my hands on one. But looking internally, there's a lot of passages, small areas. You can't guarantee you're going to be flushing everything out. So make sure that you're replacing the components that see fuel if there's a diesel fuel contamination case. Diesel exhaust fluid, look a little deeper into this. The one on the left-hand side there was a fuel sample that we had pulled out of one of the customer's trucks that had came through the door. Notice that the diesel fuel separates the top side, and the diesel exhaust fluid sits pretty heavy at the bottom. One thing to do is, if unsure if the truck came in hot and customer pulls in, the vibrations can shake the fuel up, and you're not very sure. Pull a sample and pull it on a darker towel, even a blue towel, blue shop towel. Those will be enough to crystallize. So you picture on the right hand side, let it sit there for a while, an hour, half hour, and you can start seeing it crystallize, and you can tell what kind of contaminants you have. It's kind of like this. If it smells like gasoline, one thing you could do is take a couple drops and on an approved bench and put a lighter to it. If it burns, well, it's not diesel fuel, it's a contaminant, and the issue's got to get addressed. One thing that I have seen on some forums, I don't know how many of you guys follow, but on Facebook, you got your Duramax forums, your Power Stroke forums. Excuse me, even online, you get forums, and I've been just kind of reading some of the things. What are you guys doing? Kind of what practices are we doing? How can we educate? Well, is trying to flush the DEF fluid out. And the picture that I'm about to show you in a little bit is kind of an experiment of why we don't want to try to flush things out. Why replace? Why do we want to replace, and the importance of it? So took this experiment upon myself. Did a diesel fuel and DEF fluid. Just kind of did a 50-50 mix. You try shaking that up, and it's going to separate if it hasn't been ran in the diesel fuel tank for a while. But what happened there? 24-hour period. I left that DRV valve off of a rail inside there, and immediately you could tell the rust that's being formed on the bottom, showing you how corrosive diesel exhaust fluid is. After 1 hour, I let it sit out, and you can start seeing the crystallization starting to form up on the DRV valves. So that's where I get back to the point of replacing these components and not try to flush things out. Example, the injectors. You get a DEF fluid contamination scenario. Guys want to try to flush it out, and this is my point of why we can't flush it out. We can't see internally what's going on. So with DEF fluid, in this case too, being that it's really corrosive, so inside that valve, there's a little needle that seats on the bottom to create the restriction, to create the rail pressure. Normally that needle sits open, so there's room and it's open. There's an open passage at I don't know if you can see the little orifice right in the middle, but that's where the fuel comes in, and well, contaminant would be going into it and sitting in the little seat where the Pinto would sit. So the rust being this bad out there is going to create rust internally, and it's going to erode at the seat, and it's never going to seal up properly anymore. Moving on to the debris in the fuel system. On the left-hand side, what we have here is a kind of a scale to show you what a micron is compared to a human hair. Human hair is roughly 100 microns, or in this case, we got the 71 thin hair. And the red dot there, I don't know if you guys can see it. The red dot is 1 micron. On the right-hand side, we have your fuel injector. So like I mentioned earlier, we have 2 filters typically on our vehicles, even on our off-highways. It's considered of a larger 5 micron filter, and typically we're seeing a 2 to 3 micron final filter on vehicles and off-highway applications. So tolerances inside of an injector are within 4 microns. So that's where you can see anything that were 2 microns if the final filter was 3, or if there was the incorrect filter was being used, or filter caps as well. You see guys that make the billet steel, nice aluminum filter caps. Sometimes those aren't designed to push down and seat properly. So you let debris or anything past, and going back to my 4 micron tolerance in the injectors, you get anything that's past that, well, it's going to throw it in. It's going to jam something up and cause a stuck open injector, misfire, this or that, or just over time, it's just high velocity rail pressure inside is going to eat away and erode at components. So effects of debris in the fuel system, we got erosion here at the bottom of the nozzle, the pintle nozzle, and then the pintle of the nozzle. You can notice where I've circled, we have a sealing seat starting to erode due to debris in the fuel system. So kind of symptoms towards this would be a leaky nozzle tip, so you can get some smoke, excessive amount of black smoke when needed, or engine RPM starting to hang when you snap the throttle and you let it come down. That RPM start to hang up. Debris of the fuel system. Again, here we have, this one was a brass. So this is a small piece of brass lodged in the sealing surface. So what happened here was injectors got sold out to a set of injectors got sold out to a customer. They did some cleaning, and this is where I kind of go back to the cleaning, to the cleaning. There was a brass brush that was used to clean some of the components, or some of the bores, and the feed tubes that go in the cylinder head. In this particular was a Dodge. So what happened? 10 miles. Yeah, they had like 10 miles on it, and all of a sudden it just started pouring smoke out the exhaust, and you had a really loud engine knock and a dead miss under idle. Pull them out. In the Dodges, you don't really have a cylinder cutout test with the scan tool, so customer just decided to pull them out and send them in for warranty and test them. The 5 injectors tested fine; they were good, but one of the injectors, what I did was put air to the shop air to the inlet, and we had a straight stream of fuel. After that, we disassembled the injector, and we found that piece of brass embedded down in the nozzle tip, which was hanging up the injector. So that's where I go back to the point of being clean and cleanliness with our work that we're doing. Just take that extra step, shine the light, and make sure we didn't lose a piece of brush or anything like that in down the cylinder or down inside the injector cup, or when we were cleaning the feed tube. So just kind of an FYI. And here's some more of that contamination case. made it up on the top side of the injector. So that was kind of floating around, waiting to make its way down into the spring seat. So debris can also affect on the return side. On the early 5.9 common rails, the Dodges, they used an orificed banjo bolt on the backside of the cylinder head. Didn't take much for it to plug them. So if you see something like this, like I have shown in my example, check, make sure that banjo plug is not being restricted or plugged up, or something got left behind in the return side of it. That the return side is designed to run maximum of 7 psi of return pressure. So to get where we are here with the top of the solenoid popping off in that fashion, it takes 60 psi of return pressure to make the solenoid pop off like that. So now we're having two pressures starting to meet each other, and it's got nowhere else to go and pop. It's only going to go one way. In this case, what you'll see is crankcase dilution. Dipstick level will get up pretty high. So kind of a quick tip is, if you guys have a truck that comes in blowing smoke and you suspect an injector hung up or hung open, just take a rubber tip, carefully take the rubber tip, put it on your inlet side, and if it starts squirting fuel out, well, stuck open injector, at that point that one is getting boxed up and sent back for a core because it needs to get replaced. So some more debris in the fuel system. Here we have a valve set inside of an injector. That orifice there to the right-hand side that I have circled, where you have the arrow, just to kind of give you an idea of where it is on the valve set, is around 300 microns, 0.3 millimeters in diameter. The piece of debris is smaller enough where it's still obstructing it, but it's not completely plugging it. So in this case, what happened was a stuck open injector. Inside the common rail injector, there are no seals. The amount of high pressure that it's seeing, seals would not be able to withstand the pressure, would not be able to withstand the pressures, and would blow out. So we're depending on pressures coming in back and forth to seal things properly once the solenoid's done actuated and the springs all come back down. So having that restriction in the valve seat and that orifice caused the injector to be off balance and kind of hang open and cause a free-flowing injector. So not only a piece of debris down inside the nozzle tip will cause a hung open injector, but a piece of debris that makes it into the valve set will also cause a free-flowing injector. To the right-hand side, we have the top of the valve set. So here is a pretty good example. As you can see, you're going to see there's a little bit of a star pattern going on there. Well, a piece of debris got in there. There's a ball that seats up top to help seal up and create the injection of the injector. But having anything that's a foreign material, micron, 2 micron, whatever it is, as long as it's foreign, constantly beating at it at high pressures will cause an erosion. So symptoms you see in here due to that on the engine is smoking at an idle. If you get a pretty good haze, Duramaxes, we see that, you'll see that, and what we do is have it in park and idle, ramp up the rail pressure with the scan tool, forcing that thing to seat. And once you kick up the rail pressures and the smoke starts going away, well, it's a pretty good sign that the valve seat in the injector is starting to get worn out, either from just being mileage where it gets wore out, or you got debris in the system prematurely wearing it out. So kind of give you an idea of how the whole injector is being put together. You can see the valve set, you can see the orifice, there's the valve body, and the armature. Water and fuel, as I mentioned before, it not only creates rust, but it starts cutting into the lubricity characteristics of the diesel fuel, and components start to rub it on each other, where components are out. First picture, you can see some of the rust starting to develop, and that in that area where you see the duller spot, it's kind of a no man's land, just part of the injector, not really a sealing surface, unlike the second picture. So what cutting the lubricity characteristics. You start getting a metal-to-metal rub, and if you leave the truck, it starts developing rust overnight or whatever. You get that wear. So what happens here in this case, you get that wear, and eventually you're just going to get enough bypass where it causes you cause low rail pressure, and all your return your return fuel starts spiking up. So you could either start a hard no start or a hard cranking or a hot start issue. So on the right hand side, that last picture is the valve seat of a Denso injector. Same thing of that valve seat in the Bosch and the valve set in the Bosch. Kind of the same theory where here we add the water as well, cutting the lubrication and starting to create that chatter where same thing here, the ball can't seat anymore, and you're just going to have low rail pressure and an extensive amount of return fuel coming out the return side of the circuit of the injector. As I mentioned earlier as well, the fuel system not only got your pump and your injectors, but we got our rails, and we got pop-off valves. We have your rail pressure sensor. You have your pressure control valves. All those are components that see the same fuel, and if contaminated, can throw fault codes and or can hang a valve up, and you can never make rail pressure. So again, components that we can't physically see inside and validate that we flushed everything out in a metal contamination scenario. We can't confirm everything's flushed out, so at that point we have to replace it. Otherwise, we run the risk of reintroducing contaminants inside there or having a erratic running engine. So here to the right-hand side, we have some fault codes commonly seen as affiliated with fuel contamination. I'm not saying that every time we see these fuel codes or these fault codes, we're going to go bypass everything else in our basics: fuel pressure, lift pump pressure, vacuum restrictions, make sure there's no error. We still got to do all that. We got to do our basics. Big believer in the basics. Let's cover all our basics first, and then we can focus on what's causing the issue. But typically, like I mentioned, we see these fault codes associated with contamination. When we do see things that we practice in the shop, once we do check out our lift pump, all our essential, our basics, things that we do is, depending on the vehicle, on the Fords, it's a little bit easier to take off the pressure control valve and crank the engine over without starting it and get a fuel sample from the rails. The Duramax is a little bit easier to get at that volume control valve on the top side of the pump, which is that picture there in the middle, and verify and check to see if there is any metal in there. As I mentioned before, see metal in there, at that point it's game over, and get a contamination kit on that pickup or off-highway piece of equipment. Again, good example here of not all trucks will have the symptoms of rough running or failing to build rail pressure. A good example was a 6.7 that came in with some EGR issues, so that was kind of derating the truck, but it did have a fault code in there for don't remember if it was a P0087 or just it was a rail pressure related fault code. So we checked it because the EGR valve, having it out of the way, is a good spot to check the return fuel sample out of the injectors. Cranked it over, pull the sample, found metal, advised the customer, but denied to do the repairs. We'll take it as is. Well, and this is where it turned into, well, let the customer know, hey, you're taking it, but we don't know how long it's going to last. It could be out the driveway. It could be a week, a couple days. At that point, you're a ticking time bomb. Well, he went off 6-8 months, I believe, and it was running fine. And finally get the call, hey, truck went into limp mode. It's not starting, run real sluggish, hesitating real bad. Well, we knew the history on it and still did our basic checks, make sure it wasn't anything goofy like that. But pull another fuel sample, and the importance to take pictures and tie it to the job. So we referred back to the job, compared it to what we had originally 6-8 months ago, and it got worse. So at that point, he was looking at a system, at a complete fuel system. Symptoms related to poor fuel quality. Not everything's going to throw a fault code. So crank no start, extended crank, hard start, runs rough, reduced power, smoke, fuel pressure slow to build. So those are also some symptoms due to poor diesel fuel quality and/or contamination inside the system. Tip here for you guys is for them CP4 pumps that are very disastrous. This kind of goes back, and we were just kind of discussing this morning with one of my colleagues there. It's kind of it's kind of like the VEs of back in the day, VE injection pumps as well. So it's kind of gone through the diesel, through even like the legacy is aerated fuel. So what I'd like to tell people, and even tell customers, if you guys sell filters to customers, let them know that, hey, replace that filter, but let it sit there and idle for 10 to 15 minutes before going out for a test drive. Doing that will allow air to purge out the system nice and slowly, and not let it be airbound. And once you go out for a test drive, you'll have a better chance of it being all purged out. And again, CP4 is very well sensitive to aerated fuel. Again, this is a tip that we could all practice to prevent a catastrophic failure. What to do with the fuel tank is, please go the extra mile and flush out that fuel tank and clean that thing out. I'm surprised on some calls that I've taken where they have not dropped the fuel tank and or pulled the fuel out, cleaned it out, and filled it with fresh fuel. Imagine having to do a very expensive and labor-intensive job on a contamination kit, and failing to do so, you're looking to do it again. So not only boss going to be on you, but you're going to have a customer that's going to be very, very unhappy. Good practice to do too as well is pull a fuel sample and get it sent out if there's like a lot of doubts. Get it sent out to a lab, and what we're looking at when we're sending these things out is the lubricity count. So on lubricity counts, what we should be seeing is 4 to 450 microns. The lower the number, the better. The way they do this is HFRR, or SCAR test, as I know it, is they run a steel ball across a metal plate X amount of times and at X of frequencies. Excuse me, and they see how much it wears off, and that's where the less wear, the lower the number; the more wear, the higher the number in the fuel lubricity micron count is going to be. So HFRR, there's some pretty good information out there on the web on how they do that, and it's kind of interesting. So the use of a diesel fuel additive, with Diesel Forward, we have a Alliant Power brand, and we do carry our own diesel fuel additive. It is safe on the after treatment system, and it is a demulsification additive. It's a cetane improver. We got a anti-gel protection, cleaning detergents in there to keep any sort of gummed up or anything like that in the fuel system. And again, helps remove water by demulsifying. So demulsification is a chemical reaction to suspend water molecules from the diesel fuel to let it get larger, so then they fall to the bottom of the water separator. So that's how the Alliant Power diesel fuel additive works. One thing that our diesel fuel additive does have is a stabilizer too, to maintain fuel stabilized. It's kind of some things that to look out if you're looking around for diesel fuel additives. Enhancements you can add to your customers' pickup trucks. Fast, AirDog, they make pretty good kits out there. Not only are you adding an extra source of a lift pump, for example, the Duramaxes aren't equipped with lift pumps until the L5P, the most recent one, the 2017, is when they started adding the actual lift pump. But adding a lift pump and adding that extra filtration and to give that extra protection to the fuel system. So again, you can give us a call too and pick our brain about that. With that said, again, my name is Alberto Bonilla with Diesel Forward, and thank you guys. And if you guys have any questions, feel free to reach out to us at techsupport@dieselforward.com, or feel free to chime in at 800-735-9775.
Roberto, thank you. Good insight into a lot of diesel-related issues in terms of fuel filters, so on and so forth. And I just want to remind the audience, watch for an email coming your way within a week that will have a link to your certificate of attendance and a link to the recording of the session should you want to go back and review some of the information presented here today. Dan, how about question number 1?
Thanks, Dave. Alberto, Ramon would like to know that when replacing injectors on these systems, do you have to program the injectors to the controlling module, the PCM?
Depends on the manufacturer, but now most of them, yeah. We do have a pretty good bulletin out there that shows you which, well, at least with the injectors that we offer, which generations require trim codes, which ones do not require trim code. I know Dodges get a little muddy. They stop requiring them. They required them, then they stop requiring them, and then they just required them again. I forget. I always got to refer to that sheet. So it all depends on the manufacturer, but yes, most of them do.
And then Jacob has noticed that they're having a lot more contamination codes in their facility that they're working on. He was asking whether or not the DEF quality might have gone down lately. Do you have any info on that?
Well, the DEF quality, that's more so of a DEF fluid contamination. That's where you got to take. That's a whole different topic versus having diesel fuel contamination. Again, reach out to me, and there's some tools out there where you can get fairly inexpensive refractometers to test out the DEF fluid and the DEF quality.
You were mentioning diesel treatment additives, and several of the attendees were asking, is there a particular interval that you recommend treatment to be made on these vehicles, like once a month, or what is a scheduled basis for that?
It's all personal, kind of a personal. At the end of the day, it's personal because yes, it's another expense to purchase the additive, but recommend running it year round. But if you wanted to, you could run it. You could probably get away with running it every other tank, just to keep some in there. But it's like I said, it's another expensive, and it just depends on how maintained and how protected you want to keep your trucks.
Then Andrew asks, when the discussion about checking contamination and replacing injectors, is there any suggestions that you have for removing an injector that has carbon fouling on the tip so that the piezo component doesn't become damaged during the service?
At that point, I mean, you can, where we ran into it too, I've seen it there at the shop, is you run to a point where you can't salvage, you won't be able to salvage an injector. At that point, you got to do what you got to do to get it out, and sometimes it just comes at an expense. You can only do so much to try to prevent the damage. So there are some good tools out there because we've had it where the gaskets, or you get nozzle tips that break down inside. I can't remember the name, but a couple of our customer base, they use that tool to cut seats in case something gets damaged down there.
So you had mentioned, and Jason and David are looking for some more information, but you had mentioned one of the tests for the injector was applying compressed air to that injector. I think it was looking for a dripping or fuel squirts. Was that the description?
Let me back up a couple slides in this one right here, right?
Yeah, I think that's the one. So from Jason asks or advises that you need to be really careful. We're talking about contamination, and shop air needs to be, you have to be careful with the compressed air that you're using, that it's clean.
Yeah.
And then David asks, when you're doing that test, what is the approximate pressure that should be used or applied to that?
So if you're taking shop air, which ours is like around 120, 130 PSI at our shop, if you take it and it's opened and you start seeing nozzle, it's just a check to see if that nozzle is being hung open. In all honesty, you could probably take 60 PSI and if it starts squirting fuel out of there, well then it's a done game. So it doesn't really take much to test that nozzle to see if it's stuck open or not.
And then you described a contamination kit. Is that an industry-wide terminology for that type of part setup or service?
Yes, it's what through Diesel Forward we have contamination kits. It's kind of an industry. You hear people they call us in, hey, I need a contamination kit for this 15 Duramax or this or catastrophic kits they call them too. The Ford, I think they have a kit out there and they call it a contamination kit just because of how often these occurrences are happening.
And then just to be clear, you were saying to perform a test of the diesel fuel, correct? And when does that test occur? Is that something you do before you do a flush of the tank, after you flush the tank to confirm that your flush has been acceptable or has worked well enough to be acceptable?
You can do that. Do it before. If you wanted to, you could do it after. But one thing that there was a good seminar that I had attended was taking a beaker and make sure that fluid. If you haven't flushed it yet, make sure that fluid is nice and stirred up so that way all the contaminants aren't sitting at the bottom of the tank. Otherwise, you do it overnight and everything's just going to sit at the bottom. But take it in a beaker before you drain everything. Shine your light and let everything settle kind of at the bottom. That's kind of a good way. But if you're pretty thorough and confident in what you're doing, you shouldn't have to do a sample afterwards.
And then when you talk about flushing the fuel tank, what is the best way to do that, to accomplish that?
Fresh diesel fuel. Yeah, fresh diesel fuel. Otherwise, I mean, if you use anything else, it's going to either brake clean or anything like that. Brake clean might dry up, but it's a simple just to flush everything that's there, clean everything up, and let it settle back down to the bottom, and use lint-free towels to kind of soak some of that stuff up. So don't want to be using water or gasoline or any solvents like that, but diesel fuel is the best.
And then that's an approach whether the tank is plastic or metal, correct?
Right.
I'm letting them catch up a little bit here.
It's kind of like doing a trans flush. It's kind of like doing a trans flush. You flush it out with the trans oil. Trans fluid don't want to be introducing anything else in there, so it's kind of one way to look at it.
All right, and with that, I'm going to pass this over to Dave Kappert. Alberto, thank you very much. Wonderful presentation today. Really appreciate what you've done and shared with us, so thank you.
Thank you, guys.
And Alberto, I'm going to second what Dan said. Thank you for your information today. Thanks for providing your contact information for those attendees that may want to follow up with you on other issues that weren't discussed here today. As you know, there's limitless details when it comes to some of these technical topics. So really appreciate it. Again, folks, watch for that final email coming your way, inside of a week with your certificate of attendance, a recording of this session. And that brings this session to a close. Watch your inbox for further announcements about upcoming webinars. And we hope to see you at another webinar soon. And everybody enjoy the long Labor Day weekend that's coming up. Take care, everyone. We'll see you soon.
Everybody be safe.